hi to all of my students. Now we are starting a new chapter from M3, that is Engineering Mathematics 3, section A, called as linear differential equation. This chapter is very important from exam point of view. For compulsory weightage, there will be 4 2-mark question in question number 1, that is 8 marks, and then there will be 5-mark questions in each of the sub question, and out of that 2 5-mark questions you have to attempt. Now whatever you are seeing on the screen, you can take screenshot of that as your notes. So let's start with linear differential equation. We'll go a bit slow for this chapter because this chapter is very important. As far as section A is concerned, without this chapter you cannot attempt section A fully. So what is linear differential equation? Linear differential equation has a general form, and its general form is given as a0 plus d raised to ny divided by dx raised to n plus a1 d raised to n minus 1 y divided by dx raised to n minus 1 plus a2 d raised to n minus 2 y divided by dx raised to n minus 2 plus up to an into y, and that is equals to x of x. Now why x of x came in the right hand side? There is a reason for that. Now if we consider dy by dx, it is generally called as a differentiation of function y with respect to x. Here y becomes dependent variable and x becomes independent variable. As independent variable is x, here x of x came in the right hand side. That you have to remember. जेव्हा पण इंडिपेंडंट व्हेरिएबल हा x असेल राईट हँड साईडला, x ऑफ x दॅट इज समथिंग इन टर्म्स ऑफ x असं एक फंक्शन येईल. सो ही गोष्ट नेहमी लक्षात ठेवावीच लागेल की जे इंडिपेंडंट व्हेरिएबल जे असेल तेच राईट हँड साईडला तुमचं इक्वेशन बनून येणार आहे. सो जर या इक्वेशनमध्ये इंडिपेंडंट व्हेरिएबल y असतात तर समोर y ची व्हॅल्यू असलेलं एखादं फंक्शन असतं. नाव व्हॉट इज डी? डी इज कॉल्ड ॲज अ डिफरन्शियल ऑपरेटर and its value is d by dx, where a0, a1, a2 are constants. So again, concentrate on this general form of this linear differential equation. Constant starts from a0, goes to a1, a2, a3, a4 and up to an, and derivative starts from n and then it decreases linearly and finally it becomes 0, that is y. So this general form of LD is very important from the exam point of view, because last time in the exam paper there was a question where LD was not in its general form, that is in the last term constant was not multiplied by dependent variable, and that's where student made the mistakes. So this is a common mistake. So whenever you solve the question of linear differential equation, first thing that you should remember is general form. Your LDE has to be in the general form. Now there are two conditions regarding homogeneous and non-homogeneous. So when right hand side of the equation, that is x of x, that is when x of x, that is right hand side of the equation, is 0, then the LDE is called as homogeneous LDE, right? Then when x of x or right hand side is not equals to 0, then LDE is called as non-homogeneous linear differential equation. So what we are doing in this chapter is we are trying to find out the solution for given LDE, that is given linear differential equation. We have to find solution. So if your given LDE is homogeneous means right hand side equals to 0. Then solution of this LDE is y is equals to CF. CF is called as complementary function. Now why I have taken y here? Because our dependent variable is y. Your independent variable reflects in the right hand side, and your dependent variable will be your solution. So for homogeneous LDE in this general form, y is equals to CF will be the solution of this equation. So what is CF? CF is called as complementary function. For non-homogeneous linear differential equation, y is equals to CF plus pi, that is complementary function plus particular integral. Now these are very very important rules. Without this you cannot solve any LDE. So how to solve and what is this CF and pi? There will be a note for that. Now read carefully. CF is called as complementary function. CF is called as complementary function, and complementary function depends on the roots of the equation. So whenever homogeneous equation is given to you, you have to first find a roots for it. Then according to roots, your complementary function will be decided. So CF depends on roots. Always remember this line, CF depends on roots. Now next term is pi. Pi is called as particular integral, and the pi depends on the right hand side. Means whatever the x of x is given, accordingly you have to calculate your pi. So for non-homogeneous LDE, y is equals to CF plus pi. Now this is the introductory part. Remember one line for this is CF depends on roots, pi depends on right hand side. CF depends on roots, pi depends on right hand side. This will be the tagline for this first introductory part. In next lecture or next video rather, we would say I will discuss how to calculate the roots, because CF depends on roots and according to the roots you have to write your complementary function. So up till then you just go through this lecture very keenly, understand each and every concept. Now this chapter will go a bit slower because this is a new chapter, so we'll go a bit slower. Now once we start solving problems you will understand what we are going through. ठीक.